Hello everyone. So we are watching the examples of first order RC circuits. So we have already seen first circuit and we saw that very deeply, very intuitively. Okay. We saw all the methods from writing equations to differential equation to intuitive method. Okay. Everything we have seen. Now we will see the second circuit. Okay. So in this circuit there are two switches. Let me call it first one as S1. I think I should use different color of pen. Let's call this one as S1 and this one as S2. So here it is not written in the theory, but I have told you what do S1 mean. S1 is closed before, or I should write S4 t less than 0, and S1 is opened for t greater than 0, and same goes with S2. S2 is closed for t greater than 0, and S2 is opened for t less than 0. So let's make the circuit at t less than 0. So circuit for t less than 0. What do you mean for t less than 0? That means minus infinity to 0, right? So S1 is closed, right? So S1 is closed. This is a 5-volt battery. This is resistance R. S1 is closed, right? And S2 is open. S2 is open. Right? This is open. And this is C. And this is R. Now the switch is closed for a long time, right? Switch S1 is closed for a long time. Why long time? Minus infinity to 0. What is the time? Minus infinity to 0. Infinite time, right? The switch S1 is closed for long time. For long time. And since this switch is open, this R becomes irrelevant, right? This R becomes irrelevant because this is open-ended. Let's assume some current is flowing here. Some current I is flowing here. The same current will be flowing through the capacitor, right? No current will go into this R because this will become open-ended. So this becomes irrelevant. Okay. So the switch is closed. Switch S1 is closed for a long time and it is open. So now what will happen? Now this 5-volt will charge the capacitor. 5-volt will charge the capacitor. Capacitor will get charged to 5-volt, right? This is simply this circuit. This circuit only. The switch S1 is closed for a long time. Now it will get charged depending on the value of RC. But since we have infinite time, so surely it will be charged for 5-volt. Let's assume RC value is 2 seconds. So tell me how much time it will take it to charge for 5-volt. RC tau value is 2 seconds. So how much time it will take? 5 tau, right? In the very beginning, I told you like 5 tau is the settling time, right? So how much time it would take? 10 seconds. Okay. Now we don't know the value of RC. But whatever the value is, it can't be greater than infinite, right? It can't be greater than infinite, right? Infinite is very, very large. So it can't be greater than infinite. So switch is closed for a very long time. So this capacitor will fully get charged. The capacitor will fully get charged to 5-volt. Charge to 5-volt. So now our capacitor is having 5-volt. Now what we are doing? We are opening up the switch and closing this switch. So now if I say your VC at t equals to 0 minus will be 5-volt, right? VC at t equals to 0 minus will be 5-volt. Do you agree? We are starting from We are starting from minus infinity and we are going towards 0. Right? So in meantime, somewhere here, it would have been charged to 5 volt, right? VC would have been charged to 5 volt. Now it will remain till 5 volt only. It can't get higher than 5, right? Because only 5 volt is there. So steady state value of capacitor will be 5 volt only. It can't get higher than 5 volt. So at some time it gets 5 volt and remains there, right? So this is the steady state. Steady state is 5 volt. Okay. So VC0 minus is 5 volt, or what we can draw here is that we can draw something like this. Vc with respect to time t, we are starting from minus infinity, right? So somewhere from here we are starting, and it goes till 5 volt. It can be anywhere. We don't know from where it is starting, so it goes till 5 volt and remain there. So from 0 volt to it will charge exponentially till 5 volt and it will remain there. Now circuit for t greater than 0. Now what is happening? This becomes open circuit, right? And now our capacitor is charged to 5 volt. Our capacitor is charged to 5 volt and this switch is closed now. This is R, right? This switch is closed now and this is R. So this is the condition now, right? This is 5 volt. This is R, this is C, and this is open now. So this becomes irrelevant. This side, this side is open circuit. So open circuit means irrelevant. So you can reduce the circuit something like this. You have a capacitor, you have a resistance. The capacitor is having initial 5 volt. That's it. This is the circuit. Okay. Now you can solve the circuit, right? What you do? Vc at t equals to 0 minus was 5 volt. So tell me, Vc at t equals to 0 plus will be 5 volt only. Why so? Because of the property of capacitor. Capacitor, right? Vc0 minus equals to Vc0 plus is equals to Vc0. This is the property of capacitor, but this property is valid only when there is finite current through the capacitor. So before writing this thing, okay, always see the current that is flowing through the capacitor. So tell me, what is the current flowing through the capacitor at, this is the current I we are talking about. Okay, so tell me what is the current at t equals to 0. Okay, this is one thing. Also tell me what is the current at t equals to 0. 0 plus I can say. What is the current at t equals to 0 plus? Tell me what is the value of I. Look, this is 5 volt here at capacitor. The same 5 volt will be coming towards this side. Right, the same 5 volt will be coming towards this side and the current will be flowing in this manner. If a resistance is having 5 volt across it, what is the current flowing through the resistance? That is 5 by R. And this is finite. So if this is finite, then only we can write this. Are you getting my point? Like those who have studied this chapter before, they would have always written Vc equals to 0, Vc0 minus equals to Vc0 plus. They would have always written this. But that's only true when there is a finite current through the capacitor. Now the same current that is flowing through the resistance, the same current is flowing through the capacitor, right? The current flowing out of the capacitor. The capacitor and into the resistor, right? The current flowing out of the capacitor and into the resistor. This 5 volt is there, 5 volt coming towards the resistor. That means 5 by R current is flowing. Are you getting this point? Right. So then only you can write Vc0 minus equals to Vc0 plus equals to 5 volt. Okay. So now your voltage is 5 volt. Now some current is flowing towards. Now some current is flowing in the resistor. At steady state, what will happen? Okay. At steady state, At steady state, what happens? The capacitor becomes open circuited, right? There is no current flowing through the capacitor. That's happened. At steady state, no current flow through the capacitor, right? At steady state, no current flow through the capacitor. That means this is the capacitor you are having. This is the resistor. You can make it open circuit as well. CR. The current flowing through the capacitor is 0 ampere at steady state. At steady state, the current flowing through the capacitor is 0 ampere, and this is your VC. So, what is your I? I at steady state, 0 ampere. What is your VC at steady state? Tell me. VC is equals to the voltage across the resistor. If voltage across the resistor is what? 0 volt. Right? Did you understand this point? VC is what? VC is equals to the voltage. VC is equals to VR, right? VC is equals to VR, right? The voltage across the capacitor is equals to the voltage across the resistor. So 0 ampere current is flowing through the resistor. That means 0 voltage is there, right? So in conclusion, what do you write? Simply, what do you see? I0 plus or I0 you can write. I0 you can write, or I0 plus you can write. So I0 plus was 5 by R, and I infinity was 0 ampere. So now can you write the equation of I of t? It would be 5 by R e to the power minus t upon 2. Now tell me the value of time constant. We can find the value of time constant here only. Time constant. Right? So how do we find the time constant? We are finding the time constant for t greater than 0. Right? For t greater than 0. We are finding the time constant for t greater than 0. How does the circuit look like for t greater than 0? This is how the circuit look like. Right? What is C effective? That is C. What is R equivalent? That is R only. So what is time constant? That is RC. Okay. And there is one mistake in this final expression. Can anyone mark it out? What is the mistake? 5 by R e to the power minus t upon 2. The mistake is that we will write ut here, because we are writing the equation. We are writing the equation for t greater than 0. Equation for t greater than 0. Are you getting this point? Ut means simply t greater than 0. What is ut? Ut is this. We have already seen all these things in basics. This is ut. So we are writing the equation for t greater than 0. That's why we have to apply ut here. Okay, so this is the equation of current. And you can draw the graph. It will start from 5 by R and it will go down to 0. So we will draw the graph as well. So graph of IT we will draw. This is the graph of IT we are drawing. It is starting from 5 by R, then it goes down to 0. Now tell me what is happening. What is the value of IT for t less than 0? Actually, we should have written here circuit for t less than 0. What was IT? This was I, right? This was I. But there was no current flowing through these resistors. There was no current flowing through this resistor. Why so? Because this was open circuit. So for t less than 0, I is 0 ampere. Only the current flowing was here. Only the current was flowing here. and they didn't ask the value of this current. Okay, so no worries about this current. They only ask the value for this current. So there is no current flowing through this loop, because this loop is open circuited. This loop is open circuited, so no current is flowing here. So the current is 0 ampere. So first the current is 0 ampere. Then what happens? 5 volt comes, and the current suddenly rises to 5 by R, and then goes down to 0. So this is what is happening. Okay. Starts from 0. Okay. Then suddenly rises to 5 by R, and then goes down to 0. Okay. Now let's talk about VCT. Okay. Let's talk about VCT. So VC at t equals to 0 plus. What was the value of VC at t equals to 0 plus? Here we wrote, right? 5 volt. And what was the value of VC at t equals to infinity? 0 volt. Here we wrote, right? 0 volt. This is 0 volt. So what is the complete graph of VCT? Okay, before making the graph, we will write down the equation. So your VCT would be, it will also be 5 upon e to the power minus t by tau value is RC. Okay, and also we will use UT. Okay, so beforehand it was like this. It came from some value from somewhere. It came from 0 to 5 volt. Okay, then from 5 volt to it went down to 0 volt. Right, so this is VCT, and this is 5 volt. Okay, and some people ask what is the time constant here. So time constant is RC. What is the time constant here? Time constant is RC. If in these problems that we have already seen, where are the problems? Yeah, if in these problems they ask you what is the time constant, tell me what is the time constant for these problems. I guess I have already told this thing. What is the time constant? Look, open circuit the current source. Okay, open circuit the current source. What is C effective? C only. What is R effective? From here, if you see resistance, what is the resistance? I just open circuited the current source. That's what I am supposed to do. Open circuited the current source for finding the time constant, right? For finding the time constant, I will open circuit the current source. Now this is my capacitor C. So what is my C effective? C effective is C. Now what is my R equivalent? Tell me. 0 or infinity? You have two options: 0 or infinity. Infinity. Why so? Because what does open circuit mean? Open circuit means infinite resistance. Short circuit means zero resistance. Open circuit means infinite resistance. So what is the time constant? C into infinity. Infinity. So what is the time constant for all these circuits? It is infinity. And also by concept you can also understand. What do you mean by time constant? The speed of settling down, right? The speed of transient being destroyed. But it is not even settling down. It is always increasing. So when it will settle down? At infinity time. It is always increasing. So the time constant is infinity. Okay. Circuit was having infinity time constant. Okay. Now let's understand the circuit, what is happening. So I guess all of you must have understood what is happening for t less than 0. For t less than 0, what is happening? The capacitor is being charged to 5 volt, right? From minus infinity to 0, the capacitor is being charged to 5 volt, right? Now for t greater than 0, this switch is closed, and this is R and this is C, this 5 volt. Now what happens? This same 5 volt comes across the resistor. This same 5 volt, same 5 volt comes across the resistor, right? So what happens? This same 5 volt comes across the resistor. So what happens? I is equals to 5 by R. Now just see the capacitor. What is happening? What is happening? This is the capacitor. Okay. This is charged to 5 volt, right? And this is capacitor C. 5 by R current is flowing out of the capacitor. This is at t equals to 0 plus. At t equals to 0 plus, what is happening? 5 volt, 5 by R current is flowing out of the capacitor. What is happening? 5 by R current is flowing out of the capacitor. Out of the capacitor. So if the current is flowing out of the capacitor, what happens? Capacitor discharges. Capacitor discharges. 5 by R current is flowing out of the capacitor, that means the capacitor discharges. Let's assume at t equals to t1, capacitor is discharged to 4.9 volt. Okay. So what happens at t equals to t1? At t equals to t1, what happens? Capacitor is discharged to 4.9 volt. This is your capacitor that is discharged to 4.9 volt, right? And this is a resistance R, right? So now what is the current? Current at t equals to t1, that is 4.9 by R. What is the other way of showing it? This is a capacitor with 4.9 volt across it, and again 4.9 by R current is flowing out of the capacitor. Now 4.9 R current flows out of the capacitor and discharges it. Now tell me, till what voltage it will continue to discharge? Till what voltage the capacitor will continue to discharge? 5, 4.9, 4.8, 4 volt, 3 volt, 2 volt, 1 volt, 0.5 volt. Again 0.5 R, 0.5 by R current is flowing. If capacitor is having 0.3 voltage, that means 0.3 by R current is flowing. If capacitor is having 0.1 voltage, that means 0.1 by R current is flowing. That means this shows that the capacitor will keep on discharging until the current flowing out of it becomes 0. And when does it become 0? When does it become 0? That means the capacitor will have 0 voltage. Okay. Also, what you can see, I won't write it more. Okay. So what you can see, slowly the current is getting reduced, right? The current was 5 by R, 4.9 by R, 4.7 by R, 4.6 by R. That means the speed of discharging it is reducing. Did you understand my point? Initially the current was 5 by R, 4.9 by R, 4.8 by R, 4.7 by R, 3 by R, 2 by R, 1 by R. That means the current is reducing. That means the speed of discharging is reducing. That means the voltage will go down, but it will go down slowly. So that's why we are having a exponential graph. The voltage is going down, but it is going down slowly. It's not going down like this. Like it's going down slowly like this. So that means the slope is getting reduced slowly. Okay. And eventually it goes down to 0. The slope goes down to 0. Also the current is getting reduced. So the current also goes down like this. Okay. 5 by R, 4.9 by R, 4.8 by R. That means the speed of discharging is reducing. That means the curve goes down slowly. not like this, not linearly, but slowly. So why the graph is exponential? If someone asks you why the graph is exponential, why not linear? So you can say that the current is changing. Okay, the current is changing with time. If the current was constant with time, we would have a linear graph like this, right? If current was constant with time, but current is not constant with time, the current is reducing slowly. So that's why we are having a exponential graph. Okay, so I hope you have understood the complete analysis, right? So that's how we are dealing all the circuits. Okay, so now onwards, I won't write much. Okay, I will not be writing everything. I will be telling in words, and whatever the equations and everything that we know, that we will be writing. So we won't be understanding the circuits very deeply now. We will just tell what is actually happening. If you want to write, you can write it on your own or just understand it. Okay, so this is the circuit given to you. You have to comment on VC, VR and I guess you can do it on your own. Just try writing down the equation, draw the graphs, okay, and then match it. Also, try commenting how the circuit is working, like what is happening initially, what is happening, then what is happening. Okay, so let's just solve the circuit. Okay, we won't solve by equations and everything. We will solve by the simple thing. At t equals to 0, we have to short circuit it, then we have to open circuit it. Okay, so yeah, no voltage across the capacitor initially. So circuit for t greater than 0. Okay, so what I would do, I would write 5 ut here. Okay, this is capacitor C, this is a resistor R, and this is VC, this is VR, and this is current I. What happens at t equals to 0? I will just write down here. At t equals to 0, what happens? Capacitor acts as short circuit, right? This is 5 ut, the capacitor is acting as a short circuit, and this is R, right? So this is your VR, this is your current I, and this will be your VC. So tell me, what is the value of VC at t equals to 0 plus? That is 0 volt. What is the value of VC at t equals to, sorry, not VC. Tell me, what is the value of VC at t equals to 0 first? That is 0 volt. What is the value of VC at t equals to 0 plus? That is also 0 volt. But why? Because the current flowing through the capacitor at t equals to 0 plus is 5 by R. What is the current? 5 volt and resistance R. So current is 5 by R. Since the current is finite, then only you can apply this rule. Okay. So VC 0 plus is 0 volt, I 0 plus is 5 by R, and what is VR 0 plus? That is 5 volt. Right? At 0 plus, the complete voltage is coming. Now, what is happening at t equals to infinity? At t equals to infinity. What is happening at t equals to infinity? At t equals to infinity, what happens? The capacitor becomes open circuited, right? The capacitor becomes open circuited. So this is becoming open circuited. Why it is becoming open circuited? Because it has charged fully and it can't charge more, and there can't be any current through the capacitor. Okay, this is 5 ut. Okay, and this is a resistor R. Now this is your VC and this is your VR, and this is your current. What is the current at t equals to infinity? 0 ampere, right? Because no current should flow through the capacitor. So the current is 0 ampere, right? That means your VR at infinity will be 0 volt. Because if the current is 0 flowing through it, so VR at infinity will be 0 volt. What will be VC at infinity? Let's just assume if this is ground, this is 0, this will also be 0. If this is 0, this will be 5. Right? So VC at t equals to infinity will be 5 minus 0, that means 5 volt. Are you understanding this point? At t equals to 0, you just short circuit it. So your VC is 0 volt, your I 0 plus is 5 by R, and VR 0 plus is 5 volt. And what is happening at t equals to infinity? Open circuited. So current is 0, VR is also 0 and VC is 5 volt. So your VC is getting charged from 0 to 5 volt. Your VC is getting charged from 0 to 5 volt. Your I is, what is happening with I? I is getting from 5 by R to 0 ampere, and what is happening with VR? It is going from 5 to 0 volt. Okay, so we will just write it down. So let's first write about VC. So VC 0 plus was 0 volt and VC at infinity was 5 volt. Okay, so what will be the equation of VCT? Infinity plus 0 minus infinity e to the power minus t upon tau. Now find the value of tau. So I guess I can write down the value of tau here. Time constant. Okay, tell me what will be the time constant. Just short circuit this voltage source. Okay, I am short circuiting the voltage source. So this capacitor will come like this, and this is the resistor. So what is my C effective? Again it's C. What is my R equivalent? It's R. So what is my time constant? RC. So again my time constant is RC. So what is my final equation? That is 5 into 1 minus e to the power minus t upon tau. Okay. So from 0 to 5 it will rise. VC with respect to time. So from 0 volt to 5 volt it is rising. Okay, well and good. Now next we will write VR. I can write VR. VR at 0 plus. What is happening? VR at 0 plus. VR at 0 plus was 5 volt, then it goes down to 0. 5 volt and then it goes down to 0 volt. So what will be the equation of VRT? From 5 to 0. 5 e to the power minus t upon RC. Okay, here 2 is RC. Okay, about VR with respect to time t, it is going down from 5 volt to 0 volt. Okay, now what about I? What was happening? I at 0 plus was 5 by R and I at infinity was 0 ampere. Okay, so what will be the equation of I? That would be 5 by R e to the power minus t upon RC. Okay, so it will start from 5 by R ampere and goes down to 0. It starts from 5 by R ampere and goes down to 0. So this is the equation of I t. Okay, and one more thing, always apply ut, right? Because we are dealing for t greater than 0, right? Okay. Now this is the final analysis. This is the analysis of the complete circuit. Now if someone asks you what is really happening in the circuit, understanding the circuit. Okay, the point that we mentioned before, understanding the circuit. So I am not going to write it completely, but I will just tell you. Okay, or you should think about on your own first. So what is happening? Initially the 5 by R current is flowing. So this 5 by R current will start charging the capacitor in this direction, right? This 5 by R current will start charging the capacitor. Now let's assume at t equals to t1 the capacitor is charged to 0.1 volt. Now if the capacitor is charged to 0.1 volt, tell me what is the value of I now? If the capacitor is charged to 0.1 volt, tell me the value of I. It will be 5 minus 0.1 by R. That means 4.9 by R. If here we have 5 volt, here we have 0.1 volt, that means we will be having 4.9 volt here. That means 4.9 by R. So now after some time, let's assume the capacitor is charged to 1 volt. So what will be the current? 5 minus 1 by R. That means 4 by R. So slowly the current is reducing and the capacitor is gaining some voltage. When the capacitor gains 5 volt, what will be the current? 5 minus 5 by R. That means 0 by R. That means now there is no current flowing through the capacitor. So the capacitor is charged to 5 volt, the current becomes 0. Also, you can comment on the VR waveform as well, because so slowly VR is reducing. First, when capacitor is charged to 0.1 volt, that means VR was 4.9. When capacitor is charged to 1 volt, VR was 4. When capacitor is charged to 2 volt, VR was 3. When capacitor is charged to 3 volt, VR was 2. Okay, so this is what is happening in the circuit. I'm not going to write it, but I hope you have understood what is really happening in the circuit. Right? Have you understood? We'll repeat once again. Initially, no voltage across the capacitor, so 5 by R current is flowing through the capacitor. The same current charges the capacitor. Let's assume at time t equals to t1, the capacitor is charged to 0.1, and because of the 0.1 voltage, the current flowing in the capacitor is 5 minus 0.1 by R, that is 4.9 by R. Now the current is slowly getting reduced, but the current is having the same direction. That means it will keep on charging the capacitor. So when the capacitor is charged to 5 volt, at that time the current will be 5 minus 5 by R, that means 0 by R. So this is what steady state is. This is what steady state is, and the capacitor will not charge further. So at steady state, the capacitor is having 5 volt, the current is 0, and the value of VR is 0 volt. That's it. This is what is happening in the circuit. Okay? I hope you understood the concept. Now, this is the circuit. You have to comment on VC, VR, and I. I think you should do it on your own. Okay? So, let's just see the circuit. Okay, they have already given UT. So, just see the circuit at t equals to 0. At t equals to 0. I also, you can comment on IC as well. This is IC. Okay. So at t equals to 0, what is happening at t equals to 0? The capacitor will be open circuited, right? Sorry, short circuited. Sorry. Capacitor will be short circuited. This is 5 UT. This is resistor R1, and the value across it is VR. This is R2, and this is the capacitor C. The capacitor acts as a short circuit. So what is actually happening here is that this is shorted, right? The capacitor acts as short circuited. So this is current I, right? And this is current IC. So can you tell me what is happening at t equals to 0? Let's just assume this current is I1, I will call it. This current I will call I1. So tell me what is happening. Tell me what is the value of I1 at t equals to 0? I1 at t equals to 0. Can anyone tell what is the value of I1 at t equals to 0? If the capacitor is short circuited, so will there be any current through the R resistance? No, the complete current will be flowing through the short circuit path only. So I1 will be 0 ampere. What will be the value of I at t equals to 0? Plus you can write. If this is 0, this will also be 0. So the current will be 5 by R1. 5 volt is there. This is 0. This is shorted. So this is also 0. So 5 by R1. Current is 5 by R1. Okay. What is the value of IC at t equals to 0 plus? That will be the same as I at 0 plus. That will be 5 by R1. Okay. Now tell me, what is the value of VC at t equals to 0 plus? VC at t equals to 0 plus. This is shorted, so it will be 0 volt. Now tell me, VC VR. What is the value of VR at t equals to 0 plus? What is the value of VR at t equals to 0 plus? That is 5 volt. If this is 0, this is 0, this is 5 volt. That is 5 volt. Right? So this is what is happening at t equals to 0 plus. Okay. Now let's see circuit at t equals to infinity. So at t equals to infinity, what will happen? The capacitor will act as a open circuit. Okay. Capacitor acts as a open circuit. Yeah. VC 0 0 was 0 volt. Actually, VC0 was 0 volt. VC0 was 0 volt, and that is equals to VC0 plus. Why so? Why so? VC0 is equals to VC0 plus because the current flowing through the capacitor is finite. You don't need to see this current. Neither you will see this current. You will see only this current because this is the current flowing through the capacitor. Okay, so the current flowing through the capacitor is finite. The current flowing through the capacitor is finite. Yeah. So this current is finite. Okay. So the current flowing through the capacitor is finite. So VC0 is equals to VC0 plus. Okay. Okay. So well and good. Now at t equals to infinity, what is happening? The capacitor is open circuited. Okay. This is R. This is R. Now your capacitor is open circuited. This is actually R1. This is R2. This is R1. This is R2. And this is 5 UT. Right? This is VR. And this is VC. This is IC. This is current I. Okay. So tell me, what is the value of current I at t equals to infinity? Tell me, what is the value of current? This current. Now what is happening? This is open circuited. So the circuit becomes 5 by R plus R1. R1 plus R2, sorry. 5 by R1 plus R2. Because the capacitor is open circuited. So the complete current will be flowing in this loop. So 5 by R1 plus R2. Right? Now tell me, what will be the value of I1 at infinity? What will be the value of I1 at infinity? It will be the same, right? 5 by R1 plus R2. Now tell me, what will be the value of IC at infinity? Without even watching the circuit or seeing the circuit, you can tell the current has to be 0 because the capacitor will be open circuited. So the current has to be 0. Now someone may get a doubt that, sir, the current is finite. Still there is some current flowing. So how can you say this is steady state? Steady state is in steady state, the current through the capacitor is 0. Not the current in the circuit. The current in the circuit can flow, but the current through the capacitor is 0. That means this shows steady state. Okay. You don't need to worry about all these things. You just need to worry about one thing, that is the current through the capacitor. At steady state, the current through the capacitor will be 0. That's it. Nothing else. Okay. Only one concept we know. At steady state, the current through the capacitor is 0. So the capacitor will be open circuited. Also, we know that when there is finite current flowing through the capacitor initially, then VC0 is equals to VC0 plus. Okay. And now tell me, what is the VC value at t equals to infinity? VC value at t equals to infinity. If someone says it is 5, then he is absolutely wrong. What is the value of VC at t equals to infinity? Tell me. This is open circuited. So the voltage across R2 is equals to voltage across R2 at infinity is same as voltage across the capacitor at infinity. So that will be 5 by R2 upon R1 plus R2. Right? And what is the value of VR at infinity? It will be 5 into R1 upon R1 plus R2. Simply potential divider. Nothing else. VC at infinity is 5 into R2 upon R1 plus R2. VR at infinity is 5 into R1 upon R1 plus R2. Simply potential divider, nothing else. Let me again explain it. Initially the capacitor is shorted. So the complete current is flowing through the capacitor. So the current through the capacitor is 5 by R1. The current in this I1 is, this current I is 5 by R1. Okay. And this is R2 actually. So current I1 is 5 by, sorry, the current I1 is 0 because the complete current is flowing through the short circuit path. Okay. What was the value of VR? That was 5 volt. What is the value of capacitor? What is the value of capacitor voltage? VC voltage, that was 0 volt. Okay. Now coming at t equals to infinity, the capacitor is open circuited. So the current I is 5 by R1 plus R2. The current I1 is the same because This is the only path for the current. So 5 by R1 plus R2. What is the value of IC at infinity? At steady state, the capacitor will act as open circuit. So the current will be 0 ampere. And what will be the VC value? VC value will be simply the VR value, VR2 value, sorry, VR2 value. VC value will simply be VR2 value, and VR2 is 5 into R2 upon R1 plus R2. And what will be the value of VR at infinity? That will be 5 R1 upon R1 plus R2. Okay. So now the capacitor is not completely charged to 5 volt. It is charged to 5 into R2 upon R1 plus R2. Are you getting this point? If R2 was 2R and R1 was R, so VC at so this VC at infinity would have been 2R, no? So it would be 10 by 3, right? So we will write it in on the next page. So let's just first draw the graph of VC. Okay. So graph of VC. VC at t equals to 0 plus was 0 volt. VC at t equals to infinity was 5 R2 upon R1 plus R2. So it would be 5 into 2R upon 3R. So it would be 10 by 3 volt. So how will the graph look like? VC versus T from 0 to it goes till 0 to it goes till 10 by 3. From 0 to 10 by 3 it goes. Okay. Okay, equation also I can write. VCT would have been 10 by 3 into 1 minus e to the power minus t upon 2. Now the interesting thing is tau. What is tau now? Now this is interesting. Okay, now what is the time constant? So let's make the circuit. So what we will do? We will short circuit the voltage source. So the voltage source is shorted, right? Then we have this R1 resistance, we have this R2 resistance, and we have this capacitor. I will make the capacitor here. So tell me, what is C effective? C effective is C only, right? Here you can see C effective is C only. What is R equivalent? From where you will see R equivalent? From the capacitor terminal. From here. So from here you are seeing the R equivalent. So what is the R equivalent you see? R1 parallel with R2, right? R1 parallel with R2. That means R parallel with 2R. That will give you 2R by 3. So time constant tau is 2RC by 3. Okay. Let me put it in the box. This was an important point. Okay. So what was the time constant? R1 parallel with R2 into C. R1 parallel with R2 is 2R by 3. So time constant is 2RC by 3. Okay. Understood this point? Time constant is 2R by 3. I have to add a page. I have to delete this one. Now how do I delete this one? Forget it. I will do it here. So next we will comment on, just ignore this page. Okay. Next we will comment on VR. Next we will comment on VR. Okay. So we are commenting on VR. So VR at t equals to 0 was 5 volt because this was shorted, so a complete 5 volt was coming. And VR at t equals to infinity was 5 into R1 upon R1 plus R2. That means it would have been 5R upon 3R. That means it would have been 5 by 3 volt. Okay. So what will be the final equation of VRT? At infinity it is 5 by 3 plus at 0 it is 5 minus infinity 5 by 3 e to the power minus t upon 2. So it would be 5 by 3 plus 10 by 3 e to the power minus t upon tau. So the graph would look something like this. It starts from 5 and goes down to 5 by 3. It starts from 5. This is your VRT and goes till 5 by 3. Now let's make the graph of I. Okay, let's make the graph of I. So what was our I? This was our I. The current through the resistor R1. The current through the resistor R1 was our I. So what was the value of I R1 at t equals to 0? That was 5 by R. 5 by R1. That means that was 5 by R only. And what was the value of I R1 at t equals to infinity? That was at t equals to infinity. What was happening? The complete circuit was short circuited, so it was 5 by R1 plus R2. Right? So it was 5 by R1 plus R2. Okay. So that means it was 5 by 3R. Right? 5 by 3R. So again, it is also decaying. So okay, I will write down the equation. How will I write down the equation? I R1 t. So at t equals to infinity, we have 5 by 3R. Okay. And at t equals to 0, we have 5 by R minus 5 by 3R e to the power minus t upon tau. It would be 5 by 3R plus 15 minus 10 by 3R into e to the power minus t upon tau. Right? Just writing out the equation, just the mathematics, nothing else. Okay. This is t, this is it. So it is starting from 5 by R and it goes to 5 by 3R. Okay, 5 by 3R. And the time constant is, what is the time constant that we have already found? That was 2RC by 3. 2RC by 3. Time constant is 2RC by 3. Okay, so this is the graph for I. Also, we can draw the graph for IC and I1 as well. Okay, so let's talk about IC. So what was the value of IC at t equals to 0? That was 5 by R1, right? That was 5 by R. What was the value of IC at t equals to infinity? That would have been 0 ampere, right? Let's see the circuit again. Initially, it was 5 by R1. Initially, it was 5 by R1. Then it goes down to, where is IC? Yeah, this 5 by R1. Then it goes down to 0, right? Because this is open circuited, so no current flowing. So 5 by R1 to 0, right? So IC from 5 by R to 0. Okay, and what was I1? Initially, I1 at t equals to 0 was 0 ampere, right? Because no current was flowing through this resistor. What was I1? This. Initially no current was flowing, then finally the current was 5 upon R1 plus R2. Finally the current was I at infinity would be 5 upon R1 plus R2 ampere. Okay, so this is also an, yeah, I forgot to write the equation. So for the previous one, ICT would have been exponentially decaying, so 5 by R e to the power minus t upon 2, and tau is 2RC by 3, right? And here from 0 to this one, so I1t would be from 0 to you are rising to 5 R1 plus R2, so it is 5 by 3R actually, that is 5 by 3R. From 0 to 5 by 3R you are rising, so this will be your equation. Okay, if you directly can't write it, you can write down that from formula as well. I at infinity plus I at 0 minus I at infinity into e to the power t by e to the power minus t upon 2. You can write down by that manner as well, but what happens in decaying form, it is always 5 by R e to the power minus t upon 2. Just the initial value into e to the power minus t upon 2. Because from some value it is decaying down to 0. And when initial value is 0 and final some value is there, so it is always final value into 1 minus e to the power minus t upon 2. Okay, final value into 1 minus e to the power minus t upon 2. With time you will be having the practice. Okay, you don't need to mug it up. With time you will be able to write it without writing the equation. So you will think, yeah, exponential decaying, so 5 e to the power minus t upon 2. Rising to some value, 5 into 1 minus e to the power minus t upon 2. Okay, yeah, so I1 value would be from 0 to 5 by 3R. From 0 to 5 by 3R. Okay, so this is the complete analysis of this circuit. Okay, so let's just forget this. In the next video, we will see the concept of impulse current. What really happens if there is an impulse current across the capacitor. So that I am saying, no, infinite current, infinite current, finite current, infinite current. So that concept we will see in the next video. So till now we have seen all these circuits. Okay, this circuit we have seen, this circuit we have seen. We are writing down the equation. In the exam, they may give the values, C value and R value. So you can solve the problems. We will solve the problem, but here we are developing the concept. So we will develop so much of concept that problem will be solved in seconds. Okay, I have seen like students struggling a lot in the problems. The main problem is that they are not focusing much on the concept. If you focus much on the concept, the problem will be very easy to you. Okay, we will see so much of concept that you will find no difficulty in solving most difficult problem. Okay, so yeah, so this is what is happening. This was the circuit that we have already seen, and then we saw this circuit. So in this circuit, initially the capacitor was shorted, so 5 by R current was flowing, so the capacitor was getting charged slowly. Yeah, if they ask you to explain this circuit, can you think of it? Why it got developed to 5 by R2 upon R1 plus R2 value, not to 5 volt? So if they ask you to explain this circuit, can you explain what is happening? So initially what is happening, 5 by R1 current is flowing through the capacitor. So that current charges the capacitor and it develops some voltage. Now the same voltage developed is developed across the R2 resistance as well. Let's assume the capacitor C is having 1 volt. So the same 1 volt will go at R2 resistance as well. So the R2 resistance will drive 1 by R2 current, right? Let's assume at some point it is having 1 volt. So this R2 is driving how much current? 1 by R2. How much current is coming from here? 5 minus 1. That means 4 by R1 current. So some part of 4 by R1 current is coming. That complete current is not going here. Right? That complete current is not going here. Only 4 by R1 minus 1 by R2 current is going here. Okay. Now let's just assume. Now, just for understanding the problem, what you will do, let's just assume R1 is equals to R2, R1 equals to R2 equals to R. Let's assume. Okay. So tell me at what value the capacitor will get stabilized. Let's assume R1 equals to R2 equals to R. So what will be the steady state value of capacitor voltage? That will be 2.5, right? 2.5. So let's just assume we are having 2.5 voltage here. So what will happen? This same 2.5 will come across R2. So here we will be having 2.5 by R current. Now if 2.5 is there, here we have 2.5, here we have 5. So here also we are having 2.5 by R current. So 2.5 by R current is coming, and the same current is drawn by the resistor R2, 2.5 by R. So what is the current flowing through the capacitor? 0 ampere. That means this is the steady state. Are you getting this point? Initially, 5 by R1 current was flowing, 5 by R current was flowing. So the capacitor was getting charged. But slowly, the same voltage that was across the capacitor, the same voltage R2 was having. So because of that, R2 was also drawing some current. Now R2 is also eating up some current. So the capacitor is not having the same complete current. Okay, this complete current is not being fed to the capacitor. The capacitor is having some less current. And now the capacitor is charging, and at some point 2.5, when there is a 2.5 voltage, at that time the capacitor is having zero current, and that means that is the steady state. Okay, also here you will see the capacitor is driving low current, right? Capacitor is having low current, that means it will charge slowly. So also one more thing you get to see here is that, what do you see? The time constant is also low, right? In the previous problem, what was the time constant? RC. The time constant was RC in the previous problem. But here you will see the time constant is low, 2 RC by 3 it is. So 2 by 3rd of RC. Why so? Because the capacitor is driving low current. That's why. So are you getting the practical meaning? Okay, if you don't get the practical meaning, just try getting the practical meaning, because this is very important for you. Okay, and if you just try to play with the equations, then it is also fine. You will be able to solve the problem. But if someone asks you in the interview, so that will be an issue if you just solve by the equations. Okay, they expect you to tell the concepts, like what is actually happening in the circuit. So in the interview they will expect things like that, but in the exam, in the written test, you will be able to get to the final answer by the equations only. Okay, so I have told both of the things, from equation as well, from the concept as well. Okay, so what is actually happening in the circuit. So in the next video we will see the concept of infinite current. Okay, that's very important. Okay, and I have seen like many of the educators ignore this topic, but this is one very important concept that you need to know. We have already seen the concept of impulse, right? What is impulse voltage, what is impulse current, that we have already seen. Now we will see, if it is given to a capacitor, what happens. So the infinite current is given to a capacitor. Now what will happen in the capacitor, that we will see in the next video. Okay, so if you find the videos helpful, please do share it with your friends and also like it. Okay, thank you.